Hi, Sunshines. So I wanted to talk about how to prove two triangles are congruent. So I made a proof that uses as many of these strategies as I could. So it's a pretty complicated proof, but we can totally do it. So step one is to start with your given information. Copy your given statements into your proof, and then your reason is given. And then step two is to start using all of our information. So we were given the word midpoint in our given information. We were told that point D is the midpoint of segment BC. That means that point D is cutting BC in half into two congruent smaller pieces. So those two pieces are segment BD and segment DC. So BD is congruent to DC. And then the reason is definition of midpoint because we were using a midpoint to cut it in half. If I had told you that segment AE was bisecting segment BC, then it would be definition of segment bisector. You also can have angle bisectors where you have a segment that's cutting an angle into two congruent halves. But in this case, we were given the word midpoint, so our reason is definition of midpoint. Step three is to look for your angle pairs, especially if you have parallel lines. So first you look for vertical angles. Vertical angles do not require parallel lines. That's just where you have an X, you have an intersection of two lines. So we have that here. Angle ADB and angle EDC are a pair of vertical angles. Anytime you have the X shape, the angles on opposite sides are congruent to each other. The ones above and below are also congruent to each other. They're not parts of triangles, so that doesn't help us for this particular picture. We only care about the two sides. Remember that when you're naming vertical angles, you need the three-letter name. Both of these angles have D as the vertex. So you don't know what angle you're talking about if you just say angle D. There's no such thing as just angle D in this picture because there's too many angles that could be described as angle D. You just can't use angle D. You have to use the full three-letter name. So ADB, where D is the middle letter, and EDC, where D is the middle letter. We're not done with our angle pairs. We're still on step three. We also have a pair of parallel lines. So since we were given a pair of parallel lines, this symbol here means parallel. Segment AB is parallel to segment CE, so I marked them off as parallel using the little arrows. Well, parallel lines can give us other angle pairs. You could have corresponding angles that look like this, where they're the same position. You can have alternate exterior angles where they're on opposite sides of your transversal, but they're outside of the parallel line. And your most common one for triangle proofs is alternate interior angles where they're between the parallel lines on opposite sides of the transversal. So they make that kind of like Z shape. We actually have two pairs of alternate interior angles in this picture. Angle A and angle E are alternate interior angles. Angle B and angle C also would work as alternate interior angles, but we only needed one more pair to complete our proof, so I didn't bother putting the additional pair. Step four is to look for shared sides. We don't have any of those in our picture. Our triangles are just touching each other at that one point. They're not sharing an entire segment, but this is an example of what that would look like. If you have a picture like this, then you have you'd have a pair of sides that are congruent by the reflexive property, where this segment is congruent to itself. But our proof doesn't have that, so we're going to move on. And then step five is to use your shortcuts to prove that the two triangles are congruent. So you have to look at what you have. You look at only the segments and angles that are congruent. This is not a statement of things are congruent. It was used to give us stuff that was congruent, but in itself, this statement isn't one of our three pieces. Neither is this. This is saying the lines are parallel. Again, that's not anything being congruent. You only care about the three pieces where you have that congruent symbol. So segment BD is congruent to segment DC. That's a pair of sides. Angle is congruent to angle. Angle is congruent to angle. So I have 3 statements, and my congruent symbol got kicked down. I'm sorry about that. This is supposed to say congruent in here. This is the symbol for congruent. So we have 1 pair of sides and we have 2 pairs of angles, but the order matters. We have to look at the actual triangles and make sure we know which one we're dealing with, because 2 angles and a side could be angle side angle or angle angle side. In our picture, the side that's congruent, you're caring about this one here, the one that's actually congruent, not the one that's parallel. This one here is connected to one of the angles, but it's not connecting the 2 angles to each other. So this is going to be angle, angle, side, or you could call it side, angle, angle. But you do not put the S in between. Angle, side, angle with the S in the middle would be if you had the side actually connecting the 2 angles. So now you have to look at where you're going with your proof. If you were just proving triangle is congruent to triangle, you'd be done because we said that the triangle is congruent to the triangle. That's not what we were asked to prove in this problem because I wanted to give you the hardest thing I could think of. So here we were told to prove that segment AD is congruent to segment ED. So we know that the triangles are congruent already. We also know that corresponding parts of congruent triangles are congruent. So segment AD and segment ED correspond to each other. These triangles are a rotation. So if I rotate this triangle, it's going to land on this triangle and line up perfectly because they're congruent. Segment AD and segment ED are the pieces that correspond to each other. So they're congruent because they are corresponding parts of triangles that are congruent. So corresponding parts of congruent triangles are congruent. And that's a big fat mouthful to say. So that's why we just write CPCTC. So once you prove that the triangles are congruent, then you can say that whatever piece is congruent to its corresponding piece by CPCTC. And that's the most complicated I usually get with triangle congruence proofs. You can go on to do more things when we get into the quadrilaterals chapter. We'll talk about that where we use CPCTC to prove some of the properties of quadrilaterals. But that's a video for another day. So have a great day, sunshines.